We are continuing our lesson on section 3.3. So in the video on Tuesday, I made it all the way through our examples for percentiles. In class Tuesday, I didn't get to those just yet, so we're going to start that in class today. But either way, I'm going to assign worksheet 3.3 and give you guys time tomorrow to still work on that. So what we're going to start with today are quartiles. Now, where percentiles divides our group into 100 equal parts, our data values rather, into 100 equal parts, quartiles divide our data into 4 equal parts, or 4 groups. And we denote this as just Q1, Q2, and Q3. So when we go to separate this, whatever the difference is, so we're going to have our min at one end and then our max at the other, and then we're looking at just 4 equal groups. So Q2 is what we usually find right in the middle. Now this is also associated with the median. It's the number that's right in the middle. Well, then if we took half of the lower half, that's what we call our first quartile, first or lower quartile. And then if we do the same with the upper half, we find the middle value up there. We call this the third or the upper quartile. Now we can show how they're equivalent to the percentiles. So really Q2, if that's right in the middle, that would be the 50th percentile. Q1 then would be the first 25% would be below that, so that would be the percentile, the 25th percentile, so we would say P sub 25. What do you think Q3 would be equal to? What percentile? That would be the 75th. Yep. Right in the middle between 50 and 100 here. So these are different ways that we're going to denote this. So now we're going to look at something called the interquartile range, and this is going to be useful for when we actually go to calculate and show mathematically if there are in fact any outliers to our data set. So the interquartile range, or abbreviated by IQR, what that is it's the difference between the lower and the upper quartiles, or the difference between Q1 and Q3. What it shows is the range of the middle 50% of the data. It's a rough estimate of the variability. And it's very useful when identifying outliers. So something else we're going to take a look at, we have percentiles, just showed you quartiles, which we're definitely going to work more with. But we also have something called deciles. And if you think of like a decade, it means 10. So this divides a distribution into 10 equal groups. We really don't do too much with it other than show what percentile it's going to correspond to. So here we would denote this as D1, D2, D3, or D sub 1, D sub 2, and D sub 3. So let's go ahead and say that D sub 1 would equal what percentile? And that should be the 10th. Because if we're just looking at going from 1 to 10, then P sub 10 would be where D sub 1 is. And let's go with D sub 9. What percentile would that be? So that would be, if you just did 9 times 10, that would be the 90th percentile. So just to understand what they would correspond to. But instead of looking at 100 little marks, we're just looking at 10, or with quartiles, we're just looking at 4. So let's take a look at how to identify outliers. We kind of have an idea when some values are so far away from most of the data set, we can kind of say, yeah, this looks like an outlier, but there's an actual calculation or a little test. So if you recall, an outlier is just an extremely high or an extremely low data value when compared with the rest of the data. But it actually falls within a certain range for us to really say, hey, yes, this is an outlier. And we've seen how, or how it's been described, that outliers can definitely affect the mean and the mid-range, and even the standard deviation of a variable. So there's a little bit of a process for identifying outliers. All right, the first step is we have to arrange our data in order if it's not already. And we need to use the interquartile range. So you want to go ahead and make sure that you find all of these values. So first we arrange our data in order and we find our third and first quartiles. We use that to find our interquartile range. Then we multiply our interquartile range by 1.5. Our fourth step, though, is we take, to find our lower boundary, we take our first quartile and we subtract that 1.5 times our interquartile range. And we say any value below this would be considered an outlier. The upper boundary, we take our third quartile and add 1.5 times our interquartile range. If there's any data values above that number, it's considered to be an outlier. All right, so we just have two examples to go through here to apply the quartiles and then check for outliers. So go ahead and copy these values down, but instead of copying down the way they are, we know we have to put them in order. So as you're writing them down, just go ahead and put them in order. We're going to find Q1, Q2, and Q3 for the data set. So you can pause the video as you do this. All right, so our lowest number is 5. Then we have 6, 12, 13, 15. The next we have 18, 22, and 50. Now we have 8 values. So what we want to do first is split the data into 2 halves. So that's going to be Q2, because remember Q2 is the same as finding the median. So we have 4 numbers in the lower half, 4 numbers in the upper half. So that means our median, we average the 2 middle numbers. So our Q2 is going to be right here. So if you took 13 and 15, so our median is just going to be 13 plus 15 divided by 2. We average the 2 middle numbers, and that should give us 14. So Q2 is right here at 14, or just knowing that 14 shows up right in between 13 and 15. But if they were numbers that were further away, that's all we'd have to do. Next, what we're going to do is take the lower half, the number that's right in the middle here. So if we have 4 numbers, here we go again. We have to split the difference here. We're going to find Q1. And again, what number would be right in between 6 and 12? Again, you could say 6 plus 12 over 2. So that would give us 9. And then right up here, Q3. Again, what's exactly in the middle of 18 and 22? That's going to be 20. So Q1 is 9, Q2 is 14, and Q3 is 20. Our third quartile is 20. Next, what we're going to do is test for outliers. So what we're going to do, our data is already in order. We want to find the interquartile range then, which is the difference between our third and our first quartile. So that's just going to be 20 minus 9, which gives us an 11. So we could just write this out here as our upper boundary, because all of our data values are pretty close together. We're just questioning if 50 is in fact an outlier. Is it far enough away from the rest of the data to be considered an outlier? So we're going to take, we'll just write this out as our lower boundary. The number, obviously, we shouldn't expect this because 50 is larger than than all of the numbers actually, but it's because it's on the upper end here. But we're still going to take Q1 minus 1.5 times our IQR. So our Q1 was 9 minus 1.5 times 11. You can go ahead and calculate that. Notice we are going to get a negative number, and we don't have any negative data values. When we go to find our upper boundary, that's Q3 plus 1.5 times our IQR. So that's going to be 20 plus 1.5 times 11. So looking at 9 minus 1.5 times 11, we actually get a negative 7.5. But 20 plus 1.5 times 11 actually gives us, if you didn't calculate that yet, go ahead and do that, should give us 36.5. So yes, 50 definitely is above that. So we would say, yes, 50, if I was asking that, but if we found any outliers, there are outliers. 50 is an outlier. All right, so I'm attaching a worksheet 3.3 as a separate PDF. You can go ahead and work on that, and I'm going to give you guys tomorrow to work on that as well. So on Tuesday next week, we will be starting the last section, section 3.4. It's not a long section. I go over how to construct box and whisker plots. So let me know if you guys have any questions.